There will be 7 questions where there is a definition of a function, so a function that's a few lines long, plus a function call. So there's a definition of a function, and then the question will be, if I call this function with these arguments, what is the return value, or what gets printed, or what happens when I do this? There will be 3 questions on the difference between if 2 things are equal or they're the same thing, meaning is returns true. So these are questions about the memory model. This is where you draw these boxes, which are your variables, and this other side, which is the memory, the heap, and you're supposed to figure out. Equality means that, you know, the 2 things, they basically answer yes to the equals method or true to the equals method, and is means that these 2 things are really the same thing in memory. Okay. So we've done examples of those in class. Those things may be lists, or they may be objects, or some other thing. There will be 5 questions, which are a small class hierarchy. So in fact, there'll be 3 classes. And there's some inheritance. So one of the classes, or 2 of the classes, are a subclass of one of them, or and that one of them is a superclass of the other 2. And then what you're supposed to do is answer questions about, you know, what certain pieces of code do. Okay. So this is one of the ones where there's a substantial, you know, a half-page listing of code that defines a few different classes, each of which has some methods and maybe some properties. And then 5 questions after that say, you know, if I do this piece of code, given that this class hierarchy exists, what's the result? What's the value of this code? So what does this expression evaluate to, or what does this print, or those kinds of things. Type of question you haven't seen before. There will be 4 questions that have a function. In fact, there's 4 questions about a function that has the same name. And its name is suggestive of what it's supposed to do, but it may or may not do what it's supposed to do. So don't make your answer based on the name of the function, but rather read the code of the function. It may not do what its name suggests. It's for you to figure out. So you basically have to read it and you know, decide exactly what it does. So that's sort of a skill that you hopefully some of you have developed a little bit of, because you typically write functions that are not correct the first time you write them, and then you run them and you see they don't do what you expected, which means you end up doing this kind of exercise in your head, thinking, why did my function do this when I didn't think it was supposed to? But now you're doing it without the help of the interpreter, but they're not complicated functions. Just think things through carefully. There will be 4 questions of the form, is this function fast or slow? And when the input has length, maybe 100 or maybe 10,000. So the things to remember there, you've seen a few of these questions, these types of questions on the midterm. You have also seen examples in class where we wrote pieces of code that were just slightly different. Some were very fast and the other one was very slow. The main thing to keep in mind is that if you have two nested loops, for instance, each of which you have an outer loop that runs 10,000 times, and inside of that there's an inner loop that also runs 10,000 times. Each time the outer loop executes, then that's slow. And that inner loop can sometimes be hidden. It can be something like asking if some value is in a list, in which case you need to remember that asking if something is in a list means Python just goes searching for it in the list. On the other hand, asking if something is in a set, that's a fast operation. That's not a loop at all. There will be 4 questions about sorting and binary search and sets. So these will be questions like, if I give you a sorted list, what's the best way to do this? Or if your list is not sorted, then what's the best way to do this? The things to keep in mind there are, you should remember rough approximations of log base 2 of n. Okay. So a few sort of data points. Log base 2 of 1,000, that is approximately 10. And log base 2 of, let's say, 10,000, that's approximately 13. I don't know, log base 2 of 100,000, that's approximately, I will say, 17. Okay. And so these are sort of things like, how many times does this line of code execute, or what's the fewest number of array locations you might have to look at to find something you're looking for. And the reason log base 2 comes into it is if you're doing binary search, well, the answer is usually log base 2, the length of this thing. There will be 3 questions on I'll call it algorithm analysis, but really these are questions of the form, how many times does this line of code execute? And these are not super precise questions. I'm not interested in really exact answers. In fact, the difference between the correct answer and an incorrect answer will typically be a factor of 10. So you don't have to do really precise calculations here, but you do need to be able to reason about these things. And there's not really much mathematical ability needed. As long as you can multiply by multiples of 10. So if you can take a number and multiply it by 1,000, then you're probably strong enough at arithmetic to answer these kinds of questions. There will be 2 questions that will be about recursion and analysis of, let's say, what's happening in a recursive function. So you'll be asked to reason about this recursive function. How does it work? How many, is it fast or is it slow? Maybe how many recursive calls are there? That kind of thing. And there, maybe the best way to work those things out is to, on the side, by hand, sort of, just do those pictures like I did, where you say, okay, if I call the function with this value, what happens is a stack frame gets created, the argument to the function has this value, and then it makes a recursive call, which creates another stack frame, and do that for some small inputs. That'll give you an idea of what's going on, if you don't already see it immediately. And two surprises. Okay. So that's the structure of the exam. In fact, that's exactly the order of the questions on the exam. And I think basically sort of all of this and even this and even here, so all of this would be pre-midterm type stuff, things you had all the tools to answer before the midterm. Questions about binary search and sorting, those are sort of post-midterm material, and this analysis of algorithms stuff, if you're very sharp, then you could have done this, let's say, before the midterm, though we hadn't discussed it, but the questions are asked in a very non-technical way so that you could really work them out even not having looked at any of this before. These recursion questions are sort of, I would say, also post-midterm, so not stuff that we really covered very carefully before the midterm. Okay. So that's what the exam looks like. Does anybody have any further questions for me? Yeah. I think people have already been complaining about their marks on assignment 10, so I'm guessing that some of them have been marked already. So, but that depends on exactly which TA is marking yours, I guess. Other questions? Yeah. So I'll take the best 9 out of 10 assignments, and if you have missed assignments for health reasons or other reasons like registering late for the course, then I'll take the best n-1 out of n assignments that you're supposed to be doing. Other questions? Yep.
You're not going to provide like a mock exam?
I'm not going to provide anything more detailed than this. Yeah. I think this is fairly detailed, and you have midterm exams to go from. Yep. There's no picking them up. There is going over the questions you got wrong on the midterm. So there's no picking them up. They're just little pieces of red paper that are meaningless. And so the only the only thing you can do is go over, these are the questions you got wrong. And if you don't want to come to my office and do it, send me an email. And I think the midterm is on the course webpage. Send me an email and I'll send you a list back with the questions you got wrong and what the answers should have been. Scantron nicely does that for you. Yep.
Are we able to go through a final exam too?
You can come see me sometime after the final exam and after they've gotten back from the Scantron office. Yes, I'm around most of the summer. So. But do send me an email beforehand, because I have no obligation to be in my office, and I work a lot at Ottawa U as well. So don't waste your time coming in to be on campus just to see me, unless you know that I'm going to be there for sure. So. Anything else? Okay, so that's it. Good luck on Saturday. I'll see you at the exam.